Modern intake manifolds also serve as the mounting point for many intake-related accessories and sensors. Some include a provision for mounting the thermostat and thermostat housing. In addition, connections to the intake manifolds provide a vacuum source for the exhaust gas recirculation systems, automatic transmission vacuum modulators, power brakes, heater, and air conditioning airflow control doors. Other devices located on or connected to the intake manifold include the manifold absolute pressure sensor, NOx sensor, various temperature sensor, and EGR passages. Most engines cannot produce the amount of power they should at high speeds because they don't receive enough air. This is the reason why many race cars have hood scoops. With today's body styles, hood scoops are not desirable because they increase air drag. However, to get high performance out of high-performance engines, more air must be delivered to the cylinders at high engine speeds. There are a number of ways to do this. Increasing the air delivered by the intake manifold is one of them. This can be a little tricky though. Too much airflow at the low engine speeds hurts the engine's efficiency. Therefore, manufacturers have developed manifolds that deliver more air only at high engine speeds. One such system uses a variable length intake manifold. At low speeds, the air travels though only part of the manifold on its way to the cylinders. When the engine speed reaches about 3,700 revolutions per minute, two butterfly valves open, forcing the air to take a longer route to the intake port. This increases the speed of the airflow, as well as increasing the amount of air available for the cylinders. As a result, more power is available at high speeds, without decreasing low-speed torque and fuel economy, and without increased exhaust emissions. Another approach is the use of two large intake manifold runners for each cylinder. Separating the intake runner from the intake ports is an assembly that has two bores for each cylinder. There is one bore for each runner. Both bores are open when the engine is running at high speeds. However, a butterfly valve in one of the runner is closed by the powertrain control module when the engine is operating at low speeds. This action decreases airflow speed and volume at lower engine speeds and allows for greater airflow at high engine speeds. Vacuum system. The vacuum in the intake manifold is used to operate many systems, such as emission controls, brake boosters, parking brake releases, headlight doors, heater, or air conditioners, and cruise controls. Vacuum is applied to these systems through a system of hoses and tubes that can become quite elaborate. Fuel induction system. Certain vacuum-operated devices are added to carburetors and some fuel injection throttle bodies to ease engine startup, warm and cold engine drive away, and to compensate for air conditioner load on the engine. Emission control system. While some emission control output devices are solenoid or linkage controlled, many operate on vacuum. This vacuum is usually controlled by solenoids that are opened or closed, depending on electrical signals received from the powertrain control module. Other systems use switches that are controlled by engine coolant temperature, such as a ported vacuum switch, or by ambient air, such as a temperature vacuum switch. Accessory controls. Engine vacuum is used to control operation of certain accessories, such as air conditioner or heater systems, power brake boosters, speed control components, automatic transmission vacuum modulators, and so on. Exhaust system components. The various components of the typical exhaust system include the following: exhaust manifold, exhaust pipe and seal, catalytic converter, muffler, resonator, tailpipe, heat shields, clamps, brackets, and hangers, and exhaust gas oxygen sensors. All the parts of the system are designed to conform to the available space of the vehicle's undercarriage, and yet be a safe distance above the road. Exhaust manifold. The exhaust manifold collects the burnt gases as they are expelled from the cylinders, and directs them to the exhaust pipe. Exhaust manifolds for most vehicles are made of cast or nodular iron. Many new vehicles have stamped, heavy-gauge sheet metal, or stainless steel units. Inline engines have one exhaust manifold. V-type engines have an exhaust manifold on each side of the engine. An exhaust manifold will have either 3, 4, or 6 passages, depending on the type of engine. These passages blend into a single passage at the other end, which connects to an exhaust pipe. From that point, the flow of exhaust gases continues to the catalytic converter, muffler, and tailpipe, then exits at the rear of the car. V-type engines may be equipped with a dual exhaust system that consists of 2 almost identical, but individual systems in the same vehicle. Exhaust systems are designed for particular engine chassis combinations. Exhaust system length, pipe size, and silencer size are used to tune the flow of gases within the exhaust system. Proper tuning of the exhaust manifold tubes can actually create a partial vacuum that helps draw exhaust gases out of the cylinder, improving volumetric efficiency. Separate, tuned exhaust headers can also improve efficiency by preventing the exhaust flow of another cylinder. Cylinders next to one another may release exhaust gas at about the same time. When this happens, the pressure of the exhaust gas from one cylinder can interfere with the flow from the other cylinder. With separate headers, the cylinders are isolated from one another, interference is eliminated, and the engine breathes better. The problem of interference is especially common with V8 engines. However, exhaust headers tend to improve the performance of all engines. Exhaust manifolds may also be the attaching point for the air injection reaction pipe. This pipe introduces cool air from the air injection reaction system into the exhaust stream. Some exhaust manifolds have provisions for EGR pipe. This pipe takes a sample of the exhaust gases and delivers it to the EGR valve. Also, some exhaust manifolds have a tap bore that retains the oxygen sensor.